So let's talk about how to use this tool called a stoichiometry road map. So here up at the top we have our example equation. So A and B are the coefficients. And X and Y are your compounds. So those would be, X and Y would be the formulas. Now we're just going to focus on these two because when we do stoichiometry, we can ignore everything else in the balanced chemical reaction. The only two things we need to focus on are the two different compounds that we are specifically asked about in the stoichiometry question. So we're just focusing on those two. Now, this could be two reactants, it could be two products. It doesn't necessarily have to be a reactant and a product, but the whole process works the same way. You're going from X to Y, so from one compound to another, and you're going to use the coefficients to do that. So let's start in the middle. So if we want to go from X to Y, so moles of one compound to moles of another, you're going to multiply by the mole ratio. And the mole ratio is always going to have the coefficient of the compound you're looking for. So in this case, Y is going to go on top. And the coefficient for X, what you're starting with, is going to go on the bottom. This makes it so that your units will cancel. So if we set this up down here, it would be moles X times the coefficient for Y divided by the coefficient for X. This means that our moles of X will cancel and we will be left with moles of Y at the end. So we'll multiply our number here by our coefficient for Y and then divide by our coefficient for X. So that's how we do this middle part. Now that's nice and easy, but we usually don't have just moles that we're focusing on. We're usually going from other units. So that's where the outside pieces of this roadmap come into play. So when we start with grams of X, we know we can't go straight from grams of X to grams of Y. We can't compare the masses of two different compounds. We have to go through moles. So to convert from grams to moles, you're going to divide by the molar mass of whatever compound you're looking at. So that's just a standard gram to mole conversion that we've done since about December. And then you're going to do this part in the middle, so what we just talked about. And then to get back from moles to grams at the end, so now you're focusing on Y, so you're looking with a different compound. You're going to multiply your moles of Y times your molar mass of Y, and that will get you your grams. So you need the molar mass, and remember that comes from the periodic table, so you're going to add up all the components based on the formula. So to go from grams to moles, you're going to divide by your molar mass. To go from moles to grams, you're going to multiply by your molar mass. And then to go from moles to moles, you're going to use the ratio of the coefficients from the reaction. So your periodic table values, your molar mass, are only used to go between grams and moles, or moles and grams. The coefficients from the balanced chemical reaction are only used to go between the moles to moles. Now we'll also talk about how to incorporate some of our gas laws. So say you're working with a gas and you're given pressure, volume, or temperature of X. Well, we can use our ideal gas law equation, PV equals nRT, to solve for N. So we're given all of these variables except for N. We can solve for our number of moles. And so we can use PV equals nRT to solve for N. So N would be equal to P times V divided by R times T. Remember that R is equal to 0.0821 liter atmospheres per Kelvin mole. So we'll use that equation to solve for our moles of X. And then the same type of mole ratio conversion to go from moles of X to moles of Y. And then depending on what our question asks for, maybe it asks for grams, well then we'll multiply by the molar mass to get to grams. Or maybe it asks for pressure, volume, or temperature. So then we'll use our PV equals nRT equation again to solve for one of these other variables. Because now we have N, given the two of these other three, we can solve for whatever's missing. So the central part of stoichiometry is always using this mole-to-mole ratio, which is the ratio of the coefficients from the balanced chemical reaction. We can do other steps because we know other ways to get to moles or from moles to other units, and we can tack those steps onto the beginning or the end. But this step here is always going to happen in the middle because that's the key to stoichiometry. That's how you get from one compound to another compound, is through that mole ratio. So we're going to do a bunch of practice where we use this roadmap, and hopefully eventually you will no longer have to use it.